introduced you my background, so I'll skip past that and just move into the moment. So today, this is kind of something new I'm doing here. Before I was, teaching courses more in a traditional style. Um, so at Google, we have a new service coming out for our particularly targeted at our enterprise class clients. You just for simplicity call those clients that make $1 billion or more revenue a year and buy a substantial amount of cloud services for us. So Google is unrolling, I guess you could say, or releasing a sort of a new version of its AI services for the enterprise level. It's called AI Platform Unified. Okay. Let me think. To start. So it's right now in what's called preview mode, which is kind of the equivalent of beta. It will go into GA into the near future. And one of my roles at Google is working with the enterprise companies, building them content so they can rapidly integrate our new services into their production AI. Okay? And so we've developed about 50 notebooks. Okay. These notebooks are kind of different than the traditional notebooks we used to write. You could say they were over indexed or over focused on teaching machine learning. These notebooks are more or less focused on how to integrate machine learning into a production environment. So they cover everything. It's not just training, deploying, and prediction, versioning control, how you break up things into tasks, into subtasks, and then configure them, doing large batch jobs, distributed training, custom containers, making custom serving binaries, how to debug them. So, we cover the entire sort of range of complexity. So I was talking to Bill, and we decided to sort of do a test run to see what kind of interest level there would be in his audience and this type of content. And I've selected 2 notebooks out of it, to walk through. So this is going to be more like a Twitch style. Okay, I'm just going to be walking through code. I'm not really going to be running it. I think that would take too long. But just to introduce to you what kind of content we have developed at the enterprise level for getting into production AI. Now, most of the time I'm looking at my main screen here, so I'm not seeing a chat. So once in a while, I'll flip over to the chat and double check if anybody's got a question. And right now, so okay, so double check here. Okay, nobody has a question at the moment. Okay. So let me get back to my screen. I'm still navigating back and forth. Okay. So of our notebooks, we sort of have our, what I'd call the equivalent of a hello world notebook. Okay, and this one is AutoML Image Classification. And so we walk our enterprise clients through how to set up a pipeline, a production pipeline to generate image classification models using AutoML. And a little bit of this notebook I'm going to skip because it's housekeeping. Everything from authenticating, installing, and so forth. All these notebooks are runnable on AI platform services, but they're also runnable on Colab if you have a Google AI account.
Hi, Andrew. Actually, a quick question on the Q&A. Someone is asking where is these notebooks is available to public online somewhere?
They're becoming public. They're just rolling out right now. The 2 I'll show you today, I can provide copies to Bill, and he can make them available.
Okay, sounds good.
Okay.
Thank you.
Yeah. Again, remind everybody, this is all brand new content from Google. Okay, so there might be some things here worth pointing out. Let me look. That's how you authenticate, create a bucket. Okay. Oh yeah, let's start here with the tutorial. So the way these services work, if you're not really familiar with, AI platform type services, whether it's from Google or actually any of the other cloud providers, you got to think of it as a client server model. Okay, so on the back end, Google, they have services, okay, that you can call into. These services obviously come over the network. So on your side, you have a client. How you connect to them, it might be REST, it might be RPC, or so forth. But those tend to be hidden under the covers. Okay? But you need to start off by creating clients. And so here we show the client, or the customer, not to confuse terminology, how to connect to our different services. So we have a dataset service, a model service, a pipeline service, an endpoint service, and a prediction service. All right. So the first step we show here is how to create a data set, a managed data set. And this is kind of, for some people, kind of new. Okay. So we have what we call, what we formerly called resources. Now we call them managed instances. Okay. So the only difference between a managed data set and, let's say, an unmanaged data set is that we create this wrapper around your existing data set. And that wrapper allows you to do additional things, like, for example, collect statistics on your data set. How many data items are there in the data set? What is the distribution? How many, let's say it's a classification. How many are class A? How many are class B? How many are class C? Other statistics you could have are versions. What version of this data set is it? History, things like, where was this data set used to train a model? So the first step is to simply create an empty managed data set. So this kind of just shows how we do that. So it's a client call here called create data set, and you're going to give it a name. And you can see here, in our notebook, we print some example output that you get from it, like the name you gave to the data set. Also gave the data set a data type. Is it going to have image data in it? Is it going to have tabular data in it? Is it going to have video data in it, etc.? Okay. And based on that, it also says later, when you show you how to import data, what kind of labeling you can have on there. So a data set can actually, in our managed data sets, have multiple labeling schemes. So you could have the same set of images and have one set of labeling, let's say for classification. Maybe that classification is simply cancer, not cancer. And then a whole nother labeling system, let's say for image segmentation, that actually looks at each pixel and labels every pixel, cancer, not cancer. You don't actually have two physically separated data sets. In this case, you would have one set of images, but you have two separate labeling systems that are handled inside a single managed data set. Okay, so another point here I can make, by being a managed data set, you get versioning control, you get history, and you get reuse. Both examples in different models for different types of labeling. We then show the customer how to prepare their data to do what we call import the data into the data set. Okay, and we don't actually make, the word import might be misleading because it sounds like they're making a copy of the data. We don't make a copy of their data. The import statement really just goes in and collects statistical data, builds an index, and creates statistical data. And so to do that, one needs either a CSV or a JSONL index file. To oversimplify, in the case of AutoML, if it's a CSV file, you're really going to have just two columns. One column is the path to the image. The other column is the label for the image. For more complex things like object detection, you'll have a column to the image, but then you'll have multiple more columns, things relating to the bounding box and what is the object, the class of the object in the bounding box. I'm going to quickly check if there's any questions. Oh, I see 5 messages. Okay, I don't think we have a question. Oh, somebody asked, what is class A versus class B? Just okay. That's in classification. Okay, so let's take cats and dogs. Okay, cats is one class, dogs is another class. You can say cats was class A, dogs was class B. Okay. All right. Now, when you train a model, as you, I assume here everybody's here very familiar with machine learning. You need to split your data set. You know, some of your data is used for training, some of it's test, and some of it's validation. And there's all kinds of ways you could split your data. Our enterprise customers, some of them have their unique way of doing it, and we need to be flexible. We can't just say we're going to randomly, randomize the data and do arbitrarily splitting of it. So we have different methodologies they can specify. And one of them is basically manual splitting, where they can come in and actually label the entries in their data set, which ones I want in training, which ones I want in test, and which ones I'm in validation. Otherwise, you'll be able to tell both in our AutoML product whether you want to do a randomized split based on a percentage that you can set. You can say 70% training, 20% test, 10% validation. Or you can set filter options that look at the data distribution and determine splits on that. So we give the customer a lot of flexibility so we fit into their existing production system. And that's one of the important things that we want to point out here is to use our new AI platform service, we don't want to tell our large customers that they have to do something different. And of course, here's just an example where we have example data. We put them in some public Google buckets so they can try them out. This is just showing them where it is. Okay. Of course, you always take a look at your data. And then finally, we do that import step I was talking about. Again, want to emphasize, we're not making a copy of the customer's data. We're collecting that initial statistical data for the managed data set. So and what we end up doing is, again, you specify the labeling that you're importing in here. In this case, it's going to be image classification, and the location of that index file. The index file that says, hey, here's every data element, the location of every data element, and for every data element, here is its labeling. And once you've created it, of course, it's a managed data set. Now I can query it. Okay, so that managed resource has a unique ID. Think of it like a universal unique ID, but it's universally unique within Google's services. So every managed resource, and we'll go into other ones after this, but starting with a data set really has, you can say, 2 names. One is that human readable name you gave to it when you created that managed resource, and then one that's automatically generated, that unique resource ID that we use internally in our services. Okay, so you go ahead and let's say you have that unique resource ID. You can make this call using the dataset client to get information on it. Here I just show a little bit of information. There are filters, and again, you can you know, get your versioning control. You can get your history. You can get the distribution of your elements, data items in your data set. One thing you might, of course, want to do here is, in addition to you know, the sort of high-level summary information on your data set, you might want to get summary information on every data item in the data set. Okay. Now, these calls here that I'm showing you, they're more or less create and read calls. There are other API calls to effectively do updates or edits. This allows our customers in ML operations to manage their data sets. So think of a simple scenario. You have an initial version of a data set, a model is built, it's deployed into production, it's monitored for a while, and it's not really meeting the expectations, let's say, the company had. And so that results in collecting more data, right? That new data is added back into the data set. It's now version 2. And you make a new version of a model, version 2 of the model. You deploy it. Now, most at the enterprise levels, they don't just replace the existing model out there. Call it V1. Usually do some form of A/B testing, which is something we can, our notebooks cover. So you put version 2 of the model out there, and maybe 5% of your traffic sees version 2, while 95% continues to see version 1. You do that for a period of time, you collect your statistics, you evaluate those statistics, and you make a decision whether version V2 really is better than V1 when it's deployed out there. And if you make that decision, then you use the service to redeploy it as the production model. Those are familiar with the TFX pusher element. That's sort of the terminology there would be the candidate model. V2 would be the candidate model. But now there's new statistics that have been gathered about those data elements. And again, those go back into the managed data set. Okay, I'm going to look to see if there's any questions here. I think we're okay on questions. All right. All right. Okay, so you have your training set. This is an example I've given. It's images, and the labeling is for classification. Okay. And we're going to go ahead and train it using AutoML. So instead of using a custom model, we're going to automatically make a model for you. Now, one of the things we tell our enterprise customers when they're trying to make a choice between AutoML and a custom job is we actually encourage them to do both. Okay. That is, use AutoML to set a baseline. Okay. And then if they want to try to improve on the baseline, you know, got highly skilled machine learning engineers and data scientists. They come up with a custom model. You train the custom model. We have a way of making that custom model a model resource, just like an AutoML resource, and you can do a side-by-side comparison, or the AutoML model in this case becomes the baseline, and you can ask yourself or verify, can I do even better with a custom model? But it's really straightforward. When you use AutoML, we're going to create what we call a managed training pipeline. Again, you're going to hear this phrase managed a lot. And then we're going to execute the pipeline to start the training. If you're not familiar with pipelines, this is pretty much a standard practice at the enterprise level. Think of it as think of this idea of end to end. I start off sort of with data ingestion, data preparation. Eventually, I've selected some model architecture. I'm feeding data to that model. I create a model, maybe even back up a little bit. There was some hyperparameter tuning done before we started feeding data to the model to fully train it. There's some evaluation of it. There's some model repository where I can compare evaluations for versioning control. There is some endpoint out there. We'll go deeper into what endpoints are, but think of it as like a website, somewhere where somebody can do a prediction, but it's really a virtual service. So there's load balancing, multiple copies of the models. You could be serving predictions in different geographic regions of the world, doing your A/B testing, continuous stuff. Okay, but to get all the way from step one to that last one is a pipeline. Okay, and so we provide our customers with various forms of pipelines, and you could say portions of them. And so one portion, really the upfront portion or the front end portion, is the training pipeline. So we're going to go ahead here and create a training pipeline. Some of the benefits, other benefits I hadn't yet mentioned, is they're reusable. I can build a complex pipeline that meets our company's production way of doing things, and it's configurable, and I can reuse that pipeline and just simply put in other data sets or say other model architectures, et cetera, et cetera. Okay. They can also be containerized. Pipelines can be put into a Docker container and ran as a batch job. They can also be distributed. Okay, so in the case of a training pipeline, you could be running on, distributed across multiple VM instances. And then as a pipeline, and that these are all handled by our services, every step is tracked. And so you can get both progress and history. Again, I'll sort of skip the low-level details since this is more of a talk here. So here's an example of using the pipeline service, creating a pipeline and giving a description. You could say a specification, how the pipeline is assembled and what the pipeline does. So in this case, the pipeline, first we give it a human readable name. There's a task definition. Since this is for training, AutoML training specifically, there needs to be a data set. That's your input config. This is the managed resource ID of that data set. And in this case, there's some additional information about how we want to split it. Okay, so let's assume here this is not a manually splitted data set. You're going to have AutoML do it. Two ways actually several ways you can do it, but one way is just leave it all up to AutoML and make its own best choice. Or you can, while still having it randomly split, tell AutoML the percentages you want to split it across. Okay. Also, so it's building we're going to, in the end, build this model, and we need a way to identify that model. So when you create this pipeline, the running version of it is going to, again, have a unique ID. Okay, the model that it builds is going to have a unique managed ID, but you want to give it a name. Okay, so that's what that is, giving it a name. So we go ahead and create this pipeline. There's other elements in the pipeline. Okay, you have some task stuff. Okay, one of them is, for example, your budget. Okay, What is the maximum amount of time do you want AutoML to explore finding the best possible model? Okay. Another one here is early stop. That is, you're trying to trying to manage your budget. And let's say you gave it 8 hours, but instead of using that whole 8 hours, whether you would want it to stop early if it found a fairly good candidate. That is, let's say after 3 hours, it's found a really good candidate. The question is, do you want to continue to use up those other 5 hours to see the possibility of another candidate? Of course, you're paying for those 5 hours, or just take that one. So that's what early stop here is. Okay. Also, the type of model to build here, depending on the services, like for image classification, you can build a large model for a cloud, or what we call a compact model for a mobile or IoT device. Again, I'm going to check on questions. Okay, we seem to be doing pretty good. I'm not, maybe there's 2 questions here I'm missing. No, okay. I think I got all the questions answered.
There are a few questions in the Q&A. I'm not sure, did you look at
Okay,
it?
I saw one that asked about Class A and Class B, and I got that one. Oh, I see another one here. How retraining scenarios are handled. Regular batch updates, stream, etc. Are all batches wrapped separately? Well, I'm not exactly sure of, of the question, but I think I can partially answer that. Okay. Our customers have different ways of doing retraining. Okay. In some cases, they get new data, right? And they fully retrain from scratch. Okay. Others do some form of continuous training. Okay. And even in continuous training, you can go different directions. You could just run a few additional epochs of, say, the new data set. Okay. Or you might run a few epochs of just the new data. Every customer has their way of doing it. Okay. We just make sure in our services that you can do that. Okay. So, I'm not really going to show that right here, but we definitely have that ability to manage your data set and your training that way, and to specify those things. On the question of Kubeflow, first, I'm not too familiar with Kubeflow. I use TFX. Okay. The pipelines that manage pipelines actually underneath is actually TFX. So you'll find that there's a very strong correlation between the managed pipeline services and the components in TFX. Okay. Okay, so somebody is asking a question about the methodology behind AutoML or a reference to it. And that's would be kind of a complex, there's no one answer that fits all. So we're doing image data, we're doing tabular data, we're doing vision data, language data, text data, okay? Each one of those uses a different approach. And also, even within that approach, the decisions that the AutoML service makes may change depending on the amount of data and your budget. Okay, so in the simplest case, let's say you have a modest amount of data, a couple thousand images and a few classes, maybe 10 classes, and a modest budget. AutoML will probably make what we call the most efficient cost trade-off choice, and do probably transfer learning, probably take an efficient B7 model, for example, and use it to train, but use some of its sort of search technologies to say, find the best hyperparameters, okay? But let's say you have millions of images and a massive budget. Well, that's probably going to end up triggering at some point a neural architecture search. Might start course-wise, what we call macro architecture search, taking sort of standard architectures, doing some hyperparameter tuning, some trial training runs, comparing objective results and narrowing down to a specific type of architecture. And then within that architecture might then do micro architecture search, fine tuning individual, what we call blocks. What is the best block structure within this architecture for your results? There are other types of AutoMLs, I think particularly in the very complex massive tabular end, that it uses an ensemble technique. It finds different types of model approaches, finds the best in each class, and assembles an ensemble. So I could spend a lot of time on this, but there isn't one approach that fits all. Okay, and again, now pipelines, as I mentioned, are configurable, they're reusable. So, if you're in ML ops, this just shows how to get a list of both the pipelines themselves, as well as the ones that are actively running. Okay, and then on any one of them, again, it's a managed resource, it has that unique ID. You can get, information about that pipeline on any one of them, both version, history, and how it's configured. Okay, but we have a pipeline now. We've executed a pipeline. This is an AutoML, one for AutoML version. It's training, and it'll eventually get done. So here I'm just showing some polling stuff here, waiting for it to get done. And at this point in this notebook, the model is trained. Okay. And then we just show, again, it's a managed service. That trained model now becomes what we call the managed model, right? It's got a version. It's got some characteristics. It's got some history. It's got some statistics. And it's now, since it's managed, you now have a collection of managed models. So again, in your operation, you get a list of all those managed models, okay? And any one of them, you can get specific information. But now you have a model. Let's go back to, you built a model using AutoML. There are evaluation data in it, okay? And so one of the nice things about our services is not everybody evaluates a model in the same way. I mean, one way, this is image classification. So, you can say the evaluation is pretty straightforward. What is my accuracy, for example, okay, or my precision, or my recall, okay. But some people would say, well, yes, I want that for the whole model, but I also want it on an individual class. So again, let's take cats and dogs. What is it for cats? What is it for dogs? Well, those are slices, okay? But there's other types of slices, okay? Let's say I'm doing continuous evaluation. So I have real world data that was never part of the original data set. I collected it afterwards. The previous version of the model, the customer deployed it, is out there in production, is doing predictions. The server binary is a logging mechanism. Let's say maybe one out of every 100 predictions, it's logging what the request was and what the prediction was. And maybe at some point somebody manually reviews the results, okay? And so, you know, marks where the prediction was wrong, enters what the correct prediction should have been, and so you got this sort of continuous evaluation little data set, okay? And you have some history here about how good or not good you did on it, right? Well, now that little data set could be now used as an evaluation, not necessarily part of the training data, separate from the training data, but it's another slice you want to evaluate. I train a new model. I want to see not just on the data and the training data, but did I actually really improve on that slice I have that represents the data I collected during continuous evaluation of the previous version. So again, you know, getting all the slices or any one individual slice. Again, I'll check if there's any questions. Okay. Does AutoML use convolutional neural network technique? Well, you mean a CNN? Well, ultimately for it depends what we call the task. What task is the model going to learn? And what type of data is it based on? So if the data is image data and the task is classification, yes, you're going to end up, however you got there, with a CNN, a convolutional neural network. Let's see if there's another question. Yes, the person asked, is the cost budget referred to the millinode hour budget? Yes. It's kind of strange because, you know, a millihour is it takes 1,000 to make an hour. So if you wanted to say 2 hours, you put in 2,000. Most people don't think of in terms of 1,000th of an hour. So you got to sort of think for that for a moment. Okay. Okay, so can you share a reference on ensemble method? Okay. You know, there's a lot of literature out there on ensembles. I would just encourage you just to do a Google search and, you know, find a reference that looks good for you to read. But for those who aren't really familiar with the concept of ensemble, it really goes back to a hypothesis, a mathematical hypothesis from the 1700s. There was a French mathematician, his name slips my mind right now, begins with a D, that sort of established, wrote some seminal papers, and those papers are actually became the foundation of the jury system in the Western world. And the idea, the mathematical proof he showed, is that this idea of making a good decision, okay? So if you believed people that on average made the right decision more than 50% of the time, that the more people you add, the more likely that together they will make the right decision. Conversely, if you believe that people make less than 50% of the time the right decision, the more of them you add, the more likely you'll make the wrong decision. So this is kind of the principle behind ensemble. And so what we do in ensemble is have this concept of a weak model. And a weak model is just a model that's accurate, something better than 50%, but it's not a strong model. It's not like 90, 95. It's very expensive to make strong models under certain circumstances, but very inexpensive to make weak models. So in an ensemble, another cost-effective approach is like, let's just make a bunch of weak models, all kinds of different ones. And the more and more we add collectively, the more and more likely as an ensemble, they will become the equivalent of a strong model. Okay. Gradient descent, AutoML is going to pick, it's under the covers. It's particular what it thinks is the best approach for the data type and the task being solved. Okay. Okay, how many model package libs are available there? I assume this is for the AutoML services. So they're asking for CNNs, RNNs, LSTMs, time series reinforcement learning. Right now, there's not an AutoML service for reinforcement learning. There certainly is with CNNs. There are for language, for tabular, for time series. Okay. I kind of hesitant to when you say refer to RNNs and LSTMs. Those were great models, but those model architectures are now replaced with transformer models. And so what you would get if you were doing a language or text-based model using AutoML, you're going to get some form of a transformer. Okay. All right. So we got our model, we got our statistics, it's version controlled, we have our evaluations. Now it's time to deploy them. So we want to create what's called another managed resource, an endpoint. Okay. And this might not be obvious to people what an endpoint is. And just think of it as simplicity. You have a VM that has an HTTP server on it, and it knows how to take how receiving a request, how to parse that request to pull out a prediction request. And it knows how to invoke a model, pass it to the model, receive back that prediction request, repackage it, and send it back to the client that made it. So basically, you have a VM and what we call a serving binary in it. And within that serving binary, we have a serving function. But that's a single VM. But today, to do things on a large scale, we have virtualized it. That is, you want the ability to do load balancing, okay, having multiple instances of that VM and spread volume across them. Okay, but send the request as if it was just a single VM. You might want to be able to do auto scaling. When loads are low, you have only one VM running. When loads are high, maybe you have 10 VMs running. And then, of course, like another example I gave, the A/B testing, where 95% of the instances are 95% of the requests are going to version V1 and 5% of the requests are going to V2. And you got logging infrastructure in there. Well, building all that physically and by hand is a lot of work, okay, let's say for our production people. So we give them an endpoint service where with a single instance, you can just do all that, okay? It does it all for you. That's what an endpoint is. So we create an endpoint, okay? And here I'm going to show some scaling. Okay. In this example, it's just a simple one. I just by default set the minimum max nodes to 1, which really means it's a single instance. Okay, versus manual scaling or otherwise called automatic scaling. And then when you push a model to the endpoint, as I pointed out, that endpoint could have more than one instance of that model. And so for load balancing, for example, you can say what percentage of the load, but you can also be doing it for A/B testing. Okay. So there's an argument here called traffic split. Okay, that supports both your load balancing and your A/B testing. So now I go ahead and deploy the model to that endpoint. And it's a managed resource, so you can get lists, history, version control on it. But finally, of course, you want to make a prediction. So we're going to go ahead and, come up with an example. In this case, it's, the test item is an image. Okay, I'm going to prepare it for transfer over the internet. So I'm going to do my base 64 encoding on that raw image data. Okay, you can see I'm passing it, as a request body inside, which will be put inside an HTTP request. You don't directly do all that. It's all handled by the client. And then we use the client prediction service to pass those instances to there. And it'll come back with a response object. And then the response object can be parsed to get the predictions. In this case, you can send, as many instances as you want. So every instance will have some kind of unique ID in the response. It's going to output the confidence level, between 0 and 1. I believe this is a cat, 94%. And then, of course, the actual label name, class name for that. Again, in my example, a cat. Okay, now this just shows parsing it. And of course, at some point, if you're not at the model stale, or you're not using it, or you're just experimenting, when you're done, you want to undeploy it, because as long as it's deployed on the cloud, it's, well, cost you money. So when there's no purpose to have the model anymore, of course, you want to undeploy it. I'm going to check for questions, and then it'll be a good time to take a 10-minute break. Okay, so somebody is asking about auto scaling and how it works with AutoML. Okay, it's not really AutoML, it's your endpoint. Okay, so you can send custom models also to an endpoint, and they'll effectively work the same. So I think you could sort of characterize it as 3 algorithms we have. One is single instance. There is no scaling. It's just one VM, and it's always running. Okay. Another one is manual scaling. Okay, where you specify a minimum and a maximum. Okay, at all, and then word manual might be misleading, but it just really means that at all times, the minimum number of VMs will be running regardless of the load. So if you specify 2, even if the traffic is nothing, you're still got 2 VMs running, you're still incurring costs. Okay, it uses, the endpoint service. It uses its own load balancing and, algorithm to determine when to automatically provision a new instance for you. Okay, as load goes up, and to determine when to automatically deprovision an instance as load goes down. Automatic scaling, the only real difference there is you can go down to 0. Okay, so you're really, instead of your minimum being 1 or more, your minimum is 0. So after a certain point of time of being completely idle, everything's deprovisioned. And it depends on your scenario. That might be good for your scenario. For somebody else, it may not be, because, once requests come back in, it takes a certain amount of time, might be a few minutes before you get things provisioned and up and running again. So it really depends on what your business scenario is. Do I always do an undeploy of my model at the end? Not exactly sure of the context. You would undeploy the model when you're not using it anymore. Not using it meaning you're not doing online predictions. Okay. So if you're in production, okay, and this is your business, okay, the only models you'd be undeploying would be your previous version. So you've done your A/B testing, and version 2, you're happy, you want it, you redeploy it, you undeploy version 1, and you redeploy version 2 as the 100% model. If you're experimenting, and this endpoint really might be just for internal use, other teams, maybe marketing, managers, maybe some study group or something, and so you deploy it to an endpoint for internal use, maybe for this internal evaluation period is 2 weeks long, and at the end of the 2 weeks you got your data and study's over, you undeploy the model. What Google service do you use to run this notebook? Okay, I write the notebook. I prefer to write the notebooks within Google's own notebook service. So if you are a GCP user, you have access to what's called AI Platform Notebooks. It's basically Jupyter as a hosted service. Okay, but I also write the notebooks so they can run externally under Colab. The only sort of gotcha there is, since you're using Google's services, you have to have a Google GCP account. And there's some cells at the initial of the notebook to, assuming you have an account, to authenticate yourself externally from the service. Okay, I think I got all the questions, so we'll go ahead and it's 11:00. I'm on the West Coast, the United States. It's 11:03 right now, so we'll come back at 11:13. You can see my screen. Maybe somebody can give me a yeah, good. Yeah, somebody give me a yep. Thanks. All right, so let me go back to here. All right, so I kind of gave you a brief introduction to the type of content we have for our enterprise people using AutoML services, using sort of the Hello World version. So now I'll do what's comparable for those that are doing custom jobs. Okay, and again, this is sort of our Hello version, world version of that type of notebook. It's an image classification model for online prediction. So really, the only difference, instead of being an AutoML image classification, it's a custom version. Okay. And the idea here, of course, is with our managed resources that the two can coexist together. So sort of skip the housekeeping part again here. All right. Some things are the same, of course, here. Somewhere we're going to have an endpoint when we deploy. So there's just some definitions for that endpoint service. But other things that are really additional, in custom stuff, your custom training, you have a lot more control of what we call the VMs you pick. VMs consist of multiple things. One is how many of them, and whether they have GPUs or CPUs. And if they have GPUs, what types of GPUs. We support a large number of GPUs. So you can configure what type of GPUs, if any, and how many to use both for training and for deployment. You can also pick your Docker image, the image you use for training or prediction. This one, we show what we call Google pre-built containers. These are pre-built for you, ready to go. It's not shown in this notebook, but you can also, if your company has its own container specific to its needs, you can replace using a pre-built container during training with your company's own proprietary Docker image. But there's one for both training and prediction. You can see there's various versions for TensorFlow, XGBoost, scikit-learn, and PyTorch. Machine types. Again, being able to pick different types, machine types. I won't go into all the, some people call them machine instances that are available. Google Cloud, there are a wide variety, online resources if you're not too familiar with the different types you can pick and the trick cost benefit trade-offs on them. But in here we show them how to use, how to make all those choices. Also, how many virtual CPUs you want to have on that instance in addition to your GPUs. CPUs, perform other tasks on there. For example, it's really, when you think about your data feeding and you're doing your data pre-processing as you're feeding the model, whether you're doing it upstream from the model, you'd be doing it on a CPU, and you have to have enough CPUs to not starve the GPUs that are doing the training. Or you might be doing the pre-processing downstream inside of the model. One of the things that was really promoted when TensorFlow 2 was first released. But we got customers doing both. Okay, you're doing distributed training, you're going to need CPUs for your parameter server, and etc. Quickly check if there's some initial questions. I don't. Okay, fine. Okay. All right. So let's go ahead and yes.
Hey Andrew, I see quite a few questions in the Q&A. Is this all being answered?
I hope so, because I lost my connection. I had to restart, and so when I go to Q&A, it doesn't show any past questions.
Oh, you should be able to. Can you just refresh? I think you should be able to see. I see about 5 questions, 6 questions.
Okay, so I'm going to hit the refresh. Hopefully, I won't lose connection, but let me try it. Okay, I'm back. It forced me to rejoin by doing that. And my Q&A box is still empty. You hear me out there, Bill?
Yes, did you see the 5 questions list over there?
No, it's for some reason it's not, having to it's not giving me the past. I'm not
No,
seeing.
you should be able to click the, how about the answers? Did you see answered 10 questions in answered?
Well, I was before I lost the connection. Now when I pull up the Q&A thing, it says open 0, answered 0.
Oh, okay, interesting.
Once once you go ahead and ask a question, just a test question to see if it even shows up.
Okay, so I will, okay, you know what? Let me read a few of them, and
Okay.
then for others, if you want to retype your questions in the Q&A, please do. Seems like we lost some of them. Okay, the first one is, can you tell me the methodology behind AutoML or reference to it? Is these questions already answered?
Yeah, I mean, there's certainly a lot of papers out there about automatic learning. There's such a wide variety now. I wouldn't give any one reference, but I gave it in the context of our AutoML service that uses a lot of different methodologies. And it already covered some scenarios and some of the methodologies that it used. Everything from transfer learning to macro microarchitecture search to, hyperparameter search to using ensembles, etc.
Okay, the next one is, can you elaborate a little on how auto scaling works with AutoML?
Okay, I've already answered that question.
Okay, good. Do I need always do an undeploy of my model at the end?
Oh yeah, I got that question answered.
Okay. What will happen if we do not undeploy? I guess you answered the question
Oh
too.
yeah, well, okay, on deploy, you're still being charged. You're spending money.
Okay, the last one is, what Google service do you use to run this notebook?
Oh, okay. Yeah, and I briefly touched on it, but I think I can go into a little more detail. So one of the AI services Google Cloud provides is a hosted Jupyter Notebook service. Okay. So when I'm logged into my GCP account, okay, and you see that UI, and for those who use GCP, they know in the sort of upper left corner is that little hamburger, and you can pull it down, and somewhere way down there is a section called AI, artificial intelligence, and then you have your sub options, and one of them is notebooks. Okay, and so let's go ahead, and the screen you're looking at is actually the AI notebook service. This is from my particular account. And you can see here on the left side, these are all my notebooks, okay? Okay, that I have in this one notebook instance, okay? Um, I won't go into it. You can say there's some extra special magic commands that you can do that give a little more professional usage of notebooks than the free Jupyter service, okay, or the Colab service. And I can have different notebook VMs that I launch notebooks from. Okay, so I could say I want my VM be running 2.3 and another one 2.1, or I could say I want this instance to be souped up and have 4 GPUs, and this one over here I do light work, so just give me a CPU. Again, that's all a sort of environment and cost control abilities. So what's the next question?
I think that's all.
Okay, all right. Okay. All right. So again, here's where we create clients. Now, this is a little different than the AutoML because if you think, when you submit a job, we're going to call this a job. You're going to submit a job. The service really itself has no inherent knowledge of what that job is. Okay, unlike AutoML, you explicitly tell it this is image data, and explicitly tell it this is your labeling for it, the labeling you want to use, and here's some target billing time, for example. Okay, but a custom job means you're responsible for all of that. Where is the data? What type of data it is? What's the labeling? What kind of model I'm creating? Where am I going to save my model artifacts, et cetera, et cetera, et cetera. Okay, so a few important things at the very top level is that training image. And we covered that a moment ago. You might be using a pre-built container ready to go or your own custom one. Okay, so when the job is fired off and a VM is provisioned, that Docker image is placed on there. And one of the most important things, of course, is the service has no idea anything about the final model product, let alone where it is. So you need to tell it, that's what this command does, where this script, your custom script, places the model artifacts, because we're going to need to grab those and make a managed model out of them. Okay. Then, of course, we call the worker pool spec, and this is just more for your for those who do distributed training. So, what kind of accelerators you're going to use, and the number of GPUs. Okay, and the replica count here would just indicate how many instances. So really, in the simple hierarchy of training, at the simplest level, you could say is, I'm going to use a single instance and a single CPU or single GPU. Okay, then sort of the next level up is, I'm going to use a single instance, but I'm going to use multiple GPUs. And then at the next level up, I'm going to use multiple instances, which may have one or more GPUs each. So that's kind of the hierarchy. And that's really what you're specifying here in this part of the specification. And then, of course, you put it all together, and you go ahead and use the job service to create the job. Okay. I'm going to skip a little bit here because this is sort of an empty job. I'll just show you how the job service works, and let's go get a real job so you can cancel and delete custom jobs. So in this one, we're going to go ahead and we show the customer, we use CFAR 10 as our example. We're going to go ahead and compare using a Google pre-built container to using your own custom container. Okay, and one of the additional things I hadn't showed you yet is you need to say where your training script is. So somewhere on a Google bucket, you've packaged together your training script. Okay, it's going to be a tarball. When it's installed on that provision VM, it will automatically untar that tarball. So it just gets rolled out. Okay. In the case of presumably, typically this is Python code, but it doesn't have to be Python code. It just has to, the scripts have to operate in a command manner. And so you need to specify the module that is the top level, you could say run module. In this case, in my package, I have a top level directory called trainer. And under that, I have a file called task.py. And that is the command or script I want to be invoked inside of this container. And when that script ends, that's how I know the job is done. There's no special signaling. It's just you got some application running, and as long as the application is running, the job is running, and when the application exits, that's when the job is over. Your script could have configurable arguments in it. So here we are. These are the commands to pass to that training script. In this case, I'm These are just some examples, where to put the trained model artifacts so I can retrieve them later, how many epochs to run the training data through, steps per epoch, and what type of distributed training strategy I want to use. So I got that all put together, I assemble it. This just shows a customer just an example training package used for demonstration. So I kind of will just skip through it, but this is the actual training script itself. Remember, I referred to trainer folder, and underneath it was a file called task.py. You can see here's where I'm passing the command line arguments coming in, okay? And I'm going to use those values, because this is a reusable script, for what type of, distributed training strategy. This is sort of my standard stuff here, data preparation. I build a simple CNN model, okay? And here I have, somewhere in here, where I do the fit. I use, again, the argument put in for how many epochs, how many steps, and finally, when I'm done training, where to actually save the model artifacts. So we'll move on here. I'm going to check if there's any questions. Okay. Okay, no, it looks like I got all the questions still answered. Okay. All right. So this is very similar to executing an AutoML training pipeline, but in this case, I'm just doing a job serve, using the job service instead to execute whatever this thing is in this package. Okay. And as long as it's going to come back, it's running asynchronous. I'm going to get a job ID, which is just another managed resource identifier. Okay, again, it's unique. I can get information on it while it's running. So, it's going to tell me, like, is it queued? Is it pending? It's been unqueued, but the resources haven't finished provisioning. So it's a job service. I submitted it, and your vast operations at your enterprise company could be hundreds of jobs coming in at a time. Of course, they go into a queue. While they're in the queue, they're in queue state. It gets picked from the queue. It's time to now dispatch that job. Your job specification had the provisioning specification in it, what type of VMs, what type of resources in that. So it takes a certain amount of time to physically provision those resources. So at that point, your job status is pending. It gets provisioned, and then it's going to invoke that top level script you specified with the commands. Now it's running. Okay. Eventually it exits. So if it exits with a 0 code, it's completed. If it exits with a non-zero code, it's failed. Any standard error output that came from the script would go into a log and would be available to you if you had a failed execution. All right, but at some point, it gets trained. So this is just that little loop like I did in AutoML, where I'm just monitoring the status, and eventually it gets done. Okay. Now, I got the model artifacts up in, actually I specified a GCS bucket for where the script to save the model artifacts. Of course, it's going to be one of my own buckets. Now, in many cases, in these types of custom models, the model you trained, while you could test it locally, like in a notebook, you can't really deploy it as is. Okay, and that is, and this was put in a more simpler way. Okay, you have some kind of client application. Let's say you're an internet company and you have a social media type of service. You're okay, and your users, your members post pictures, and let's say it comes back with captions for the pictures. Okay, how that application sends the data to the model, it's got to go to an HTTP server, and how that HTTP server extracts that data, packages it up, sends it to the model, gets the response from the model, and repackages it as a response is all very specific to your corporate operation. So you're going to define what we call a serving function that goes into a serving binary. And you might use an off-the-shelf serving binary or even a custom serving binary. And here we're assuming you're using an off-the-shelf serving binary. So we're just going to show you how to add the serving function. So the first thing is you're going to want to do is download the model artifacts locally. In this case, since I'm on AIP platform notebook instance, I'm actually downloading it to the VM instance behind my notebook. Okay. And since this was sort of a black box training, unlike AutoML, I have no built-in evaluations for it. So I got to manually evaluate my model. So since I've downloaded, this is an example where I get some test data from it and I locally evaluate the model. Okay, and let's say I'm happy with the model. Now I want to upload it for serving. And again, you need a serving function. Okay, so I won't go into too much detail, but in this case, we're making the assumption that you're sending your image as a compressed JPEG image. Okay, and the model takes its input is an uncompressed image. Okay, raw bytes. Also, in images, the values or pixels are single byte integer between 0 and 255, and during training you normalize the data, you turn them into a 4-byte float 32, and you rescale them, or you could say, or to between 0 and 1. You normalize the pixel data. Well, I have to repeat that. Okay, so in this case, with the serving function, that image, instead, that compressed JPEG image, instead of going straight to the model, goes to the preprocessed unit in the serving function, decompresses that JPEG image into RAW, converts the integer data types to float 32. Also, you might have a certain size of the image for the model. Well, of course you do. In this case, it's CFAR, 32 by 32. Who knows what the image size was that come in? It needs to be resized. And then finally, you do your normalization. So I've snapped this onto as a serving function. Again, won't go into too much detail, but here's a point where, in a sense, I'm going to fuse the serving function to the model. Okay, and I'm going to tell the HTTP server here that when it gets a request, to send the request to the serving function instead of the model. Okay, so I think I can kind of skip a little bit of that. Here we also show you serving functions can be really tricky. Okay, because it's like any other piece of application code. The first time you write it, you probably got a bug, right? And you don't really know if something is wrong until you've fused a serving function to the model and deployed it on an endpoint. Well, the problem is that endpoint is remote inside of a container. Have fun debugging it. You can try to put together all kinds of container logging, but you got to get to the logs, you got to decipher it. It can take a lot of time. So in here we show the client how to recreate the serving binary serving function, or emulate the serving binary and recreate the serving function locally on your VM instance, so you can just debug it locally. Okay, but now you're happy with your custom model and the serving function. So let me quickly check if there's any questions. Again, I'm not seeing any, I don't, wait a minute. Oh, okay, there's a new question here. A bit confused. You train the model using training data set and deploy the model using validation test set. I see where you're confused. Okay, so we had this custom job. We provisioned some VM instances and some GPUs, and the script ran. We really don't know what's the service has no idea what's happening inside of the script, just that it exits and it exits 0, which means it's done. But we passed an ARC command line argument to it that we remembered. The location of the model the model artifacts. And in the script, it used that command argument to actually save the trained model to it. So it's somewhere on a GCS bucket. But at this point, we may not know the evaluation data, especially if we didn't write it, make it part of the script, and somehow transmit it back to us. So we download a copy of the model, okay, locally VM, and we just do our evaluation there. So the deployment really has nothing to do, the evaluation really didn't have anything to do with changing the model. It was just getting data on the model. And we use that evaluation data sort of in our V1, V2 decision. Is this model better than the previous version? Okay. Now we're ready to deploy it. But again, you're using some kind of generic container, particularly if you're using a generic container and a generic serving function, it really knows nothing about the input and output of your model. And neither does the HTTP server. Okay, and so you need to write that glue code that goes from the request to the serving function to the model, and the response coming back from the model to the HTTP server, packaged up as a response, and send back to the requester. Okay, so that's what we were just showing you, how to write that serving function, also how to debug it locally, because it'd be painful to debug it live on an endpoint, okay, and then how to fuse the serving function to the model. Okay, but now you got this great segue. So you got locally on your local VM instance, whether it's a notebook or just any your laptop or a workstation or whatever, but everything's put together. The trained model artifacts are there, the serving function, they're fused together. Now you're ready to convert this model into a managed resource. So remember, AutoML does basically all of this, but it automatically makes it a managed resource. So this extra step here takes the custom model and makes a managed resource out of it. Okay. And some of the things you might need is dependencies, that model, you want to give that model when it's deployed, or what kind of container, is this going to be a pre-built container? Is it going to be, a custom container? And what port are you going to communicate to it on? Okay. Also, another thing that's important is to have the ability to sort of query the health of the model. Is the model really running or not? Okay, because the serving function really doesn't really know what's happening, say, behind it. And so you can create what we call a health mechanism. So this is a sort of a separate ML operations that is periodically querying the deployed endpoints, the models on them, to make sure they're still healthy, they're still running. And that's like a ping. And so that's a separate route than what we'd say the prediction route. So again, you have that capability there. Again, it's now like AutoML, it's another managed model. You get a list of all your models, managed models, custom ones along with the AutoML. Each one has a unique resource ID, so you can get information on any one specific. And then really these next steps are basically the same. I'm going to create an endpoint. Here's my scaling. I want to deploy the model to the endpoint. Again, similar things like traffic split, how many replicas, again, for my scaling, what kind of machine instance is there, what kind of container, et cetera, et cetera. Finally, it's deployed. Okay, and then I can make a prediction. So here's just the code I have using the predict service, sending a prediction request to it. And then, of course, at some point, if I'm done using the model, I would undeploy it to so I don't continue to incur costs. So I think that's kind of a wrap up there of the two notebooks. If there's some additional questions, I'd love to answer them. And I know Bill would be really eager in getting feedback from people about what they think of this content. And so he can make future planning about doing a full-fledged future course.
Great. Thanks, Andrew. So do you have anything to cover? Or this is the end of the notebook?
No, I didn't. I'm not sure what you're asking.
No. Do you have anything else to cover?
No. I was going to, I was just going to present two notebooks, the Hello World version for AutoML and the Hello World version for custom jobs. And we got to the end of both of them. Okay. Somebody's asking how will this notebook be published? Okay. So we have quite a large number of them. The content team back at work is working, getting them into GitHub. Okay. So they'll be just globally, publicly available. What I'm doing is these two ones, I'm going to make a copy of them and send the copy to Bill. Okay. And then, Bill, you can find some mechanism to distribute to them. I just kind of ask, don't publish them publicly or stuff like that, just because there's an implication that they're officially supported. And until we go through the internal process, they're not officially supported content.
Right. Yes.
Because
I can
there's a bug or a typo or something, we're supposed to correct it. But right now in the status, we're not correcting anything.
Okay. Do we have any other questions? By the way, you can type the questions in the chat or in the Q&A. Or if you want to speak to us questions, it's time to raise your hand. We can unmute you to speak.
Yeah, it'd be nice to hear somebody talk, their comments about what they thought of this content.
I think in earlier time, I saw a few people raise a hand, but that again, if you prefer to speak, ask questions, feel free to raise your hand.